welcome to the beginning of what is going to be the greatest series on mathematical knowledge ever created by a student in grade 11 in CDI in Slot G. But it's still going to be wonderful. It is known as the Chow way, where we get insight into how I think and how I successfully solve any equation that my math teacher gives me most of the time. This will teach you mathematical knowledge, how to think like me, how to analyze a problem, how to figure out an elegant solution, and your mind will rival no one else because you will be on top. So let me wear my tuxedo or my suit for this final occasion before I show you how to solve systems of equations effectively, elegantly. Like Chow. So the Chow way has 3 tenets, and number 1 is the most important. Math is fun. So why is this the most important rule? And that's because when you're doing something, if it's not fun, you won't enjoy it. You won't enjoy doing it, and you'll likely make mistakes. So you gotta make it fun. And when you make math fun, you achieve greatness. So let's do number 2. And this is mastery through practice. So what does mastery through practice mean? It means that if you want to master something, you gotta practice it a lot. And this is how you learn math effectively, like me. So what you want to do is do your math questions, pay attention in class. Because if you don't, you get questions wrong because you're not experienced. And if you don't like doing it, the only way to get better is through practice. For example, I hate cheating. I do not condone academic dishonesty, which is why I cheat on every single exam. And that was a joke. And number 3, this one is complicated but elegant. Simplicity over or greater than. Simplicity is greater than complexity. Now, what does that mean? It means that a simplest solution is probably the best one. The simplest does not mean shortest. If it makes more sense to you do it another way, do that other way. Unless the teacher asks you for a certain method, do which one you found it easiest. Be simple rather than be complex. So let's do a question for a work sample. And so I'm going to do number 3. And this says you gotta solve a system of equations. So the first one is 6x squared. Take away an x, subtract y is equal to -1. And the second equation is 4x squared, subtract 4x, subtract y is equal to -6. And now we don't need this sheet anymore because we're going to teach you how to solve it by yourself. So there's 2 ways of solving systems of equations. So it is a system as 2 equations, and you have to solve for x and y. So what the 2 ways is elimination or substitution. So which way should you do? Both of them, because we are masters of the Chow way of mathematics, and we're going to follow step 2, mastery by practicing. So we're going to practice both of these methods. But on a test, we only need one. Which one should you do? So the pros of elimination is that it can be faster than substitution. And substitution can be faster than elimination. So what I look for in an equation to see which one I find I should do is if there's one variable that has nothing on it. So both of these y's are by itself. There's no numbers, not like 2y or 3y, just negative y and negative y. So what does this mean? It means that we just do a subtraction or addition statement to get rid of this y. So elimination can work when a variable has no coefficients. So when would substitution be a good choice? Now, me personally, I think substitution makes more sense mathematically. And it can be faster if you can't figure out how to eliminate one variable. So should you look for elimination first? That's up to you. Me personally, if I don't see that one of these variables are already isolated or have no coefficients, I'll just go out by default to substitution. So just choose which method you want to do. And I'm going to show you both ways so you have an idea of both of them and you can practice it by yourself. Because at the end of the day, elimination and substitution will both give you the same quadratic at the end. So it doesn't matter what method, because you always get the same answer if you do it correctly. So let's start with elimination. So first thing I see, these two y's have no coefficients. And if they're both negative, or both have the same sign, we subtract the equations to get rid of them. And at different signs, we add them together. So let's say y subtract y is equal to 0. So same sign, they're both positive. Now let's say they're both negative. The negative y take away another negative y. So two negatives, negative, negative, plus, plus, add the opposite, and we get 0. So that's a trick I use, and to speed you up when it comes to test time. So let's put this idea to practice. So we'll take away this bottom equation. Why are we taking away the 4x squared, not 6x squared? Now, when I see this, I see 6 is greater than 4, so we are left with a positive x squared term. And I just have to be positive in life. And that's another rule. So 6 take away 4, you get 2x squared. Now, negative x take away a negative 4, add the opposite x, negative 1x, is an imaginary 1 here as the coefficient. Take away a negative 4, so we're adding on 4, that's a plus 3x. Now, negative y, take away negative y, we're adding on a y to a negative y, and that gives us no y's, so we're going to leave that at 0, and negative 6, positive 6. Negative 1 plus a positive 6, we get 5. So that's how we got it through elimination. Now let's solve it through substitution. I'm going to just write down this quadratic right now. And if you want, we could just put this 5 back in. So 2x squared plus 3x subtract 5 is equal to 0. So this is our quadratic. So I'll just put it here just to keep it safe. So how does substitution work? Well, what substituting is, we're substituting in a variable for another variable. So if we do, let's say 1 plus 2 is equal to x, and then we have x, plus 5 is equal to 8, these two x's are the same. And so we can do 1 plus 2 plus 5, and that's equal to 8. So that's 3 plus 5 is equal to 8. So that's basically substitution in a nutshell. You're just assigning a value to a variable and you just put it back in one equation. So what variable should we use? Now, I like to use the y term because y has no coefficient, has no power. So it should be just simple. And all we need to do is just put the y on the other side of the equal sign. Now how do we do that? I think you think of this as a railway. So here is an amazing drawing. And that's like the sign or something. I don't know how railways work. We don't have them where I live. So let's have a y here. And a -1 as negative y. So when y goes over to this side, there's like a toll booth. And a toll booth's like, you need to pay a payment to change your, to the other side, you just need to change your sign. So that turns into a positive y when a y comes over, and when a -1 comes over, you have to change the sign as payment, and it turns to +1. So that's basically all it is. Because you think about it, just add y to both sides. You're adding a y here, and a y here. Negative y plus positive y, and we get 0. That's basically what we're doing. And I have y by itself as a positive. So which equation would I use? So just looking at these two equations, I think this one is much easier to solve because this one looks more complicated. It has a higher coefficient of 4, 1 is simpler. So I'm going to change this y over. So this is going to turn into 4x squared, subtract 4x. Now -6 goes to the other side, change the sign, plus 6, and that's equal to y, because the y is going over, switching spots, changing its sign. Y. And now y and y. So this here is equal to that. So let's just plug this back in here and got a new equation. So 6x squared, subtract x, subtract 4x squared, subtract 4x plus 6. And that is equal to -1. Now put these in parentheses, because this makes it more simple, because sometimes you have a negative sign. That means there's an imaginary -1 here. -1 times y. So distribute this -1 all over to all these terms. So let's do that now. Yeah, 6x subtract x. Now -1 times 4, we get -4. Subtract 4x squared. -1 subtract times 4x. Negative times negative, positive. Plus 4x. -1 times positive 6, we get -6. Subtract 6, and that's equal to -1. And now all we need to do now is just group the like terms. So this should be 6x squared. That was a test to European attention. Another Chow tenet. Always pay attention. Which is true mastery, true practice. Think about it. So group these like terms. 6x squared, take away 4x squared. X's together. Plus 4x, subtract x. Now, we're left with only has one term where it has no variables, just subtract 6 equals to -1. And now, 6 subtract 4, 2x squared. 4 subtract 1, plus 3x, and -6 equals -1. Now, just put a -1 back in to make it equals 0. 2x squared plus 3x. So adding 1 to both sides to get rid of this -1, because -1 plus 1 is 0. So -6 plus 1 is -5 equals 0. And now we got our new quadratic, which is the same thing as here. It's like magic, but it's not, because it's always a trick, and a trick is through knowledge. So now let's just write down our quadratic equation. So it's 2x squared plus 3x subtract 5, and that is equal to 0. So how can we solve for x? There's three ways that you normally do it. Factoring the quadratic formula and completing a square. So which way should you do it? What is the pros and what is the cons? Factoring is the fastest. It is incredibly fast to do. It has the least amount of calculations. However, the roots has to be numbers that will work. Numbers have to work for factoring. Because when you have imaginary roots, you can't factor that, and then that wouldn't work. So if the numbers look like they can be factored, I'll recommend factoring. But if they don't, you have to do quadratic formula completing the square. So what is the pros and what is the cons? The quadratic formula is the second fastest because you already have a formula, just plug the numbers in and equals. So that is second fastest. Now, what's the con? Well, it requires the memorization of the quadratic formula, and some teachers include it, some don't. You probably already have it memorized, you should already have it memorized. So negative b plus minus square root of b squared subtract 4ac over 2a. That's the quadratic formula. You memorize that to use the quadratic formula. Some people, if they can't memorize it, then they're forced to use completing the square. And maybe you just don't like using formulas. Me personally, I'm not that big of a fan of using formulas. And that's why it's simplicity over complexity. Why use this when you can complete the square? And sure, it might be the slowest. However, it makes most sense mathematically. Instead of just plugging in the numbers to a formula, where to get the formula from? Yes, you derive it, but do you know how to derive it? I don't know how to derive it. Am I going to learn? Probably. I probably would learn it for fun. But completing a square just requires natural mathematics. And so, I personally like completing a square. And you also get bragging rights. And it just looks cooler. Because these two are basic, that's more cool. So how are we going to solve it? With all three ways. Because mastery through practice. So this is going to be a table of all our methods and our answers. So factor, quadratic formula, and completing squares. So I'm going to CS. So let's start with factoring. So first what we're going to do is factors of a and c. So quadratic equation, ax squared plus bx plus c. So that's your a term, your b term, your c term. So factors of a and c. So 2 times negative 5 is negative 10. And you have sum of 3. And this could be another kind of factoring. Maybe you just can't find the factors. And you gotta rely on something else. You also take time. So 5 plus negative 2 is 3. Negative 2 times 5 is 10. So that works. So how do we go on from here? Now, there is a secret way of factoring known as the Barnes method. And this way is faster, quicker. I like it more. But some teachers don't know it exists. And if you are going to use this secret method I'm going to show you, I recommend just talk to your teacher before it happens. But you might think you're using some kind of app. Which really, you kind of are. It's just how good it is. It's like you're in a marathon and you have a bike. It's like cheating, but ethical. It saves you time. So this is how it works. So first thing first, we get the greatest common denominator. So what I look for, prime numbers. If there's a prime number in there, that means there's no greatest common denominators. So 2 prime, 3 is prime, 5 is prime, so we're good. And now, see these factors of 2, negative 2, and 5? You do x plus the factor 1, negative 2, over the a terms, that's 2. And then you do the same thing for the other factors, so x plus 5 over 2. And now just simplify these fractions. X plus negative 1, which is simplified to x subtract 1. And now 5 over 2, that's a fraction, it's a proper number. It doesn't look the greatest, it kind of looks weird, out of place. So a trick is to just take the denominator, put it where? Next to x as a coefficient, and leave the 5 to stay. If you think about it, this is all we're doing. X plus 5 over 2, we're modifying both sides by 2. So 2x, and 2 times anything over 2 will give you the numerator, which is 5 plus 5. Now we're left with 2x plus 5, and this is our factored form. Now we go back to the original method, and that's known as decomposition. And how that works, you're splitting up the b term into these factors. So 2x squared plus negative 2x plus 5x subtract 5, and we're equal to 0. But let's write that down anyway, so good practice. Mastery through practice. So now what we do is we split them up. So I split it up here, and I split them up here. And we find common factors. So 2x squared plus negative 2x, there's a common factor of 2 and x. So I'll take that out. So 2x times, so 2x squared divided by 2x, you just get x. And 2x squared, 2x divided by negative 2x, so 2x, you just get negative 1. Now right here, what's common factor? There's only 5, so 5 is our common factor, plus 5, and then x subtract 1. Now notice how these two are the same, that means you're on the right track. If they're two different, you gotta restart, you did something wrong. And instead of trying to factor it, you just go to your correct formula, or go to complete the square. Just in case, is what I would do, because I don't want to try to figure out my problem when there's another solution that could give me an easier way. And now we group these two terms together, so 2x plus 5, and then these two are the same, so you keep that as x subtract 1 is equal to 0. And this is also equal to 0, because this was equal to 0. And now, here are the two factors, exact same thing. So, you can choose which one you like more. I like this way more, it seems simpler, seems faster. And it's more secretive, so you have that. You need to be like, I know a secret method to get through this. So how do you solve for x with this factor form? So when it has no coefficients, easy. Just do the opposite. So it's x subtract 1 equals to 0. Because if anything times 0 is 0. So add 1 to both sides, x is equal to 1. So this one answer here, x is equal to 1. And what about for 2x plus 5? Let's do the same thing. Make that equal 0. 2x is equal to negative 5, because we're subtracting 5 on both sides. And now we're going to divide it by 2 to isolate the x. So x is equal to negative 5 over 2. And if you look back up, that's the same thing here. 5 over 2, just take the opposite, negative 5 over 2. So you already have your roots in the very first step if you do it with the Barnes way. And you want more information on that, there is a link in the description, because I will be uploading this to YouTube as well, just to get some more views and to get more people with the Chow way. So now we have the roots, and now let's just get the roots with every other method to prove that it will always be the same. So it doesn't matter what method you choose, just choose the one that you like best. Because simplicity over complexity. So now let's solve it with the quadratic formula for our second method. So what is your quadratic formula? And that is negative b plus minus the square root of b squared subtract 4ac. That's all over 2a. So here is our quadratic, ax squared plus bx plus c. So this term is our a term, this term is our b term, and this term is our c term. So all we need to do is plug these numbers in, and we get x. So we have negative b, so 3 was negative sign, so negative 3 plus minus the square root of 3 squared, subtract 4 times a, which is 2, and c, which is negative 5. And that's all over 2 times a, which is 2. So now we do both sides of the fraction, do the numerator and the denominator, it wouldn't matter. So I'm going to do 2 steps at a time just to save time. The negative 3 plus minus the square root of 3 squared, that's 9, subtract 4 times 2 times negative 5. 2 times 2, that's 4. And now we do these multiplication statements to figure out what our discriminant is. And the discriminant is what's underneath the square root sign. -3 plus minus the square root of 9 take away 4 times 2, we have 8. And 8 times -5 is 40. And it's a -40 because it's a -5. As a negative times a positive, it gives you a negative number. But you have a negative sign here, so that's -9 take away a -40 over 4. And this, remember, add the opposite is 9 plus 40. -3 plus minus the square root of 49 over 4. So now here comes a common mathematical misconception. What is the square root? How does it work? Now, x squared is equal to 4. What is x? Now, x is equal to plus minus 2. And that is because two negatives multiply each other gives you a positive number, and two positive numbers give you a positive number. But if you do the root of 4 is equal to x is only equal to 2. It does not take -2 as an answer. Why? Because the square root is a function that only gives you the principal square root, and the principal square root is the positive version. And if you have a graph and we have y is equal to the root of x, the graph will look something like this. Because it's taking the principal square root of x, which is positive numbers, because this is positive, negative. Positive here, negative here, positive, negative is positive. Now, if it didn't take this and take both and a negative version, it would also come as something like this, and this wouldn't work. Why? The vertical line test. Let's see if this is a function. 2 points, same line. It's not a function. And so that's why the mathematician said the square root sign gives you the principal square root, which is the positive number. And so you need plus minus, which is why you have this plus minus sign. So let's do it here. So -3 plus minus the root of 49. What's the root of 49? 7 over 4. So -3 plus 7, that can give you 4 over 4 is equal to 1. And then -3 take away 7, that's -10. Because you're adding on two negatives. Add the opposite. Plus a -7, -3 plus -7, -10 over 4. And now we have to simplify that because both these numbers can be divisible by 2. And simplifying fractions just look better. Simplicity over complexity. That gives you -5 over 2. And this is our two roots. 1 and -5 over 2. And if you look at that, we have the exact same answers. So now we reach where I bring to you my favorite method to figuring out how to solve quadratics, called completing a square. So what is completing a square? So let's say we start with this binomial x plus d. And we're squaring it. This is a square. This is where the square and completing a square comes from. So let's factor it or expand it out to see what it becomes. So x plus d multiplied by x plus d. And now we're going to use a technique called FOIL, where we just multiply every single term by every single term. So x times x, and then x times d, d times x, and then d times d. So x times x is x squared, plus x times d, dx, then d times x plus dx, and d times d, we get d squared. And now we simplify these terms together, dx plus dx is 2dx. If you think about it, what's the quadratic? ax squared plus bx plus c. A is equal to 1 because there's no number there. Because 1 times any number is that number. Now, b is 2d. Because look, it's next to the x where it has the power of 1. X has the power of 1, 2d is next to it. Whereas b is equal to 2d. And then d squared is c. because they're both the constants. So that would be c is equal to d squared. So now we're going to try to change this quadratic to a form where it could be rooted until you get x plus d, because now x doesn't have a power. This is what putting a square really is, just figuring out how to square the trinomial. So the first thing we want to do is get a to be 1. So right now a is 2. How to get 2 to be 1? We divide it by 2. Because any number divided by any number will give you 1 unless it's 0. And then it's undefined and breaks mathematics. So 2 divided by 2 is 1. 3 divided by 2 is 3 over 2. And negative 5 over 2 is negative 5 over 2. And 0 over 2 is 0. So now what we do is we take this constant. This has no variable in it, so we just put it to the other side, so we don't need to deal with it for now. So x plus 3x over 2 is equal to 5 over 2. Now we have to find what d is. Remember how b is equal to 2d. So we figure out what b is, so b will be 3 over 2, and then we divide it by 2 because b is equal to 2d. So let's just make it so d is the subject. So divide both sides by 2, b over 2 is equal to d. So take the b term, divide by 2. X plus, now how can we divide 3 over 2 by 2? To do this, if we express it as a fraction, we have what I like to call a fraction tower. So how can we get that to what looks better? Now, there's a thing where you do KCF, keep, change, and flip. It's almost like KFC. So 3 over 2, and then dividing by 2, we're keeping this, we're changing this to the other side, so we're multiplying, and we're flipping the 2. So the reciprocal of 2 is 1 over 2, but multiply this by 1 over 2. So now 3 plus 1, so we're going to keep this x plus, we're adding this term of d squared, so 3 times 1 is 3, and 2 times 2 is 4. And we're going to square it because c is equal to d squared. Now it looks like we just added a random term, a random number. So you gotta do this to both sides. So this is equal to 5 over 2 plus 3 over 4 squared. And now we just simplify these numbers. So x plus 3x over 2. Now a squared, so ab squared is the same thing as a squared over b squared. So that is equal to that. So 3 squared is 9 and 4 squared is 16. So I just add 9 over 16 is equal to 5 over 2, 3 squared, 9, and 4 squared, 16. And now we express this to be our trinomial. Remember, x plus d. D squared, 2d. So we want to get, this is d by itself, 3 over 4. So therefore x plus 3 over 4 is equal to 5 plus 9 over 16. 5 over 2 plus 9 over 16. So how do we add fractions? Now what you want to do is try to have the same denominator. So 5 over 2 plus 9 over 16, we multiply just this fraction by 8, and then since 2 times 8 is 16, so 5 times 8 is 40, and 2 times 8 is 16, so now we get 49 over 16. And there should be a square sign here, because that will FOIL out to that. And now we're going to root both sides of the equation, so x plus 3 over 4 is equal to the root of 49 over 16 to get rid of this square sign. Now here's a misconception in mathematics, is that the square root sign won't give you the principal square root. But since remember when I explained to you how x squared can give you two positive values, we were missing a plus minus. So now we just square root this term. And like how a fraction squared could just be represented as a squared over b squared, a rooted fraction can be represented as, so root of a over b is the same thing as root a over root b. Now we have x plus 3 over 4 is equal to the root of 49, which is 7, and the root of 16 is 4. So let's isolate the x by putting this constant on the other side. So x is equal to plus minus 7 over 4 So take away, because we're subtracting this 3 over 4, 3 over 4. So -7 over 4, take away 3 over 4. So -7, and we're taking away 3. So add the opposite, that is -10 over 4, which would give us -5 over 2, because we have to simplify this, remember? So this gives us one value of x. X equal to -5 over 2. Our second value, we're going to use the other sign. Since we used the -7, we're going to use the +7. So +7 over 4, take away 3 over 4, give us 4 over 4, and that is equal to 1. So that's our second root. X is equal to 1. So we write that here. So we have two of the same answers using 3 different methods. Because math makes sense. And now you just pick which one you like the best and use that and practice the other ones just in case we might need them. You never know when you want to show off that you know how to complete the square. So what do we go from here? We have our x values and now we need the y. So go back to our original equation, and if I can remember correctly, so these are our two equations, and now what we want to do is plug in x back into this to see what y is. So I'm going to use the same equation because 4x squared seems much easier than multiplied by 6. So let's put in 1 first. So 4 times 1 squared, you're taking away 4 times 1, subtract y, you don't know what y is, and give -6. Now we're going to solve for y. So that's 1 squared is 1, so 4 times 1 is 4, 4 times 1 is 4, so 4 take away 4, take away y is equal to -6. So 0 subtract y is equal to -6, which means that y is equal to 6. So let's just write this here. Y is equal to 6. And we say that one of our solutions is 1 and 6. Take the 1 from our x and a 6 from the y, what y is equal to. And now we do the same thing again, but with this x term, the -5 over 2, because we have two possible answers. So 4 times -5 over 2 squared, subtract 4 times -5 over 2, take away y. But I'm going to shortcut, because simplicity over complexity, remember how we switched these two in the beginning? I'm going to do it again. So +6 is equal to y. Now, let's figure out this. So -5 squared, negative times negative, positive. So 5 squared is 25, 2 squared is 4. So 4 times 25 over 4, take away 4 times -5 over 2. So 4 times -5, that's really 4 over 1. So 4 times -5 is -20. Over 1 times 2, 2. Plus 6 equal to y. Now remember when I said 4 over 1? So that's 4 over 1. And now we just multiply these together. And when the numerator is in this denominator, these just cancel out, and we're left with 25. So really what we're doing is multiplying this by that and dividing it by that. So 4 times 25, just divide by 4. Because what happens, 4 times 25, that's 100. 100 divided by 4 is 25. So now we just get 25, take away -20 over 2. That's a fraction. We simplify that to be -10. And it's negative, so we're adding 10. And add 6 to give us y. So 25 plus 10 is 35 plus 6 is 41. It's equal to y. And that's our second answer. -5 over 2 and 41. But is this over now? No. Let's check with the next one, just to make sure that we have it right. So let's plug in the x and the y and see if it equals to -1. So 6 times x squared. So we got these are two possible solutions, 1 and 6, or -5 over 2 and 41. So let's do 1 and 6 first. So 6x squared, so 6 times 1 squared, take away 1, take away y, which is 6, and see what it equals to. So So 1 squared, 1. 6 times 1 is 6. Take away 1, take away 6. So 6 take away 6 here is 0, take away 1. Negative 1 is equal to negative 1. So a valid solution is equal to 1 and 6. We know this one works. And what about our second one? 6 times negative 5 over 2 squared, take away negative 5 over 2, take away 41, and see this gives us negative 1. So 5 over 2 squared is 25 over 4, plus 5 over 2, add the opposite, subtract 41. And now let's multiply this term together, see what this will equal to. So 6 times 25, that is same as 4 times 25 plus 2 times 25, we'll split up to 6. Now 4 times 25, that's easy, that's 100, and 2 times 25, that's 50. So we know that this is equal to 150 over 4. Now plus 5 over 2, subtract 41. So now, both of these numbers are even. So let's simplify that before we add 5 over 2. So divide by both sides by 2, we get 75 over 2 plus 5 over 2, subtract 41. And look, we both have the same numbers already. So it works out perfectly. So 75 plus 5 is 80 over 2, subtract 41. So it's 80 over 2, that's 40. 40 is take away 41, and we're left with a negative 1. And look, negative 1 is equal to negative 1. So this is proof that the other solution is negative 5 over 2 and 41. So now we have our solutions. Where is the intercepts of the graph? Because this is what the graph might look like. It probably won't. So this is just a sketch of two basic graphs. It does not represent these graphs. But if you look, there's two intersection points, one here and one here. Those are what the solutions are. And this graph is not to scale, obviously. But that's just a visualization of what possible solutions could look like. So now you know how to algebraically solve two systems of equations like a genius with the Chow way of thinking. Thank you for watching.